This recording, we're going to build on what we already know, the sort of the basics of transformations, and try to apply them with some more challenging examples. So this is for those students who really like a challenge and need a challenge. Okay, so this first problem is a little bit complicated. We've got a graphical representation of the function f, so it's not written out in function equation form. But what it's saying is g of x is defined as take f of x minus 2, where f of the quantity x minus 2. So let's start by evaluating each of these 3 points, and I'll walk you through the first part, and you can do b and c. So what this is saying is to do g of negative 3, all right, we need to come up here, and g is found by doing f of that particular x value of negative 3 minus 2. Okay, so essentially we're going to find out what f of negative 3 minus 2 is. So we're going to put that in. So it would be f of negative 3 minus 2. So essentially that's finding out f of negative 5, right? So you're going to go over here and find f of negative 5, and that's going to end up being negative 6. You're going to plot that point. So when the x value of g is negative 3, the y value of g is negative 6. So I'm going to go over here to negative 3 and plot a point right here. Okay, I want you to do the same for b and c, and then play the recording when you're ready, please. Okay, so for g of 0, I'm going to first find out it's going to be f of 0 minus 2. I'm subbing in the 0 into the x, taking away 2. Okay, so that becomes f of negative 2. And then f of negative 2 ends up being this point right here. In other words, when on this graph, when the x value is negative 2, the y value is 3. Okay, so now I'm going to plot the point. On the g graph, when x is 0, y is 3. All right, and finally, when I'm on this point here for 4, sub that in, we're talking about f of 4 minus 2, which is the same as f of 2. I have to consult my graph to find out what f of 2 is. So I go 2 in the x direction, works out to be negative 3. And now I'm going to plot the point 4 comma negative 3. So 1, 2, 3, 4, down 3. All right, and let's make this graph so I can plot the points. And you can see that it has a behavior. And take a moment to reflect. What behavior would you have expected to see from this function that has a minus 2 inside? And did that in fact do what you thought it would do? And I think we can say, yeah, it definitely shifted to the right as we thought it would. All right, this graph is a basic parabola. And you've got 2 different things to do. It wants you to graph and label negative f of x and f of negative x. Right? So why don't you do as much as you can with this and then play the recording when you're ready. All right, so for this one, the negative f of x, we're going to negate the y value for each particular value of x. So I'm going to take that y value, which was negative 3, and keeping the same x, I'm going to negate it. So that reflects it over here. For this particular x value, I'm going to negate negative 2, or 2 to negative 2. For this particular x value, it's going to become a negative 5. And this one is a negative 6, etc. Okay? So you basically reflected it over the x-axis as we would expect it to have done with, that's a little bit off, I'm going to touch that up. We would have expected that to be the case with a negative in front. Okay. This next example is a little bit challenging to understand, but if you give it your best effort and possibly rewind the recording to try to really get it, you will get it. All right, so what this instruction says is you're going to take a particular x value, negate it, and find out what the y value is for that point and plot it. So let's take a particular number like x equals 1. All right, so when x equals 1, we're going to sub in a 1 here. Find out what f of negative 1 is. So let's read the graph. So we go to negative 1. It's right there. So when x equals 1, we should have the same y value. I'm going to plot that point right here. Okay? And so what you can see is the behavior is it reflected it across the y-axis. Let's do one other one. Let's sub in when x equals 2, for example. Okay? So when x equals 2, we're going to find out what f of negative 2 is. Okay, and that's this point right here. Keep the same y value for when x equals 2, and you can see it reflected right across the the y-axis. So all our points are going to be reflected across our x-axis, and we'll do our best to draw a smooth curve. Now this one doesn't reflect at all because it is on the y-axis. All right, and then we're just going to draw a smooth curve the best we can. Mine don't always turn out so great on this recording device, but I'll do my best. And you should do the same using a pencil. We always use pencil for graphs. All right, finally. This is a tricky one. Why don't you read this over and get as far as you can, and then play the recording when you're ready. All right, so first off, it says, show the function passes through the origin. Well, that just means the origin is just the point 0, 0, right? So that's just basically saying f of 0 when x is 0. So let's sub in 0 for x, and we get 0. And so that means, yeah, the point 0, 0 is on that function, right? How has the function been shifted to produce the function g? Well, you can see the differences here. We have the 2x, we have the 2x, but there's a minus 2 there. So hopefully you would say that that is a shift down of 2 units. All right, and then write it in factored form. Well, that's going to look something like this. You can factor out that greatest common factor. We always want to take out the greatest common factor first, and that's going to be the factored form. All right, and then so what it says is, all right, if you look at the original g of x, it looks like it's down 2 units, but now when we look at this other form of it, well, what's different about it? It still has the 2, but now inside the parentheses there's a minus 1. So think about what that transformation would be. And hopefully you would say it's a shift to the right 1 unit. And the question is, well, how can there be 2 transformations that describe the same function if it is in fact the same function? And the line is a weird animal. So let's look at the graphs of those, and you can just kind of see this is the graph of 2x, and this is the graph of 2x minus 2, or its factored form. And you can see shift to the right or shift down. Both. Thanks for watching.